Hello to everyone. Today we talk about my project of the Advanced Data Management course of the University of Genova during the year 2022-2023. We talk about what are the fault tolerance process approaches in large-scale distributed system. So what is fault tolerance? Fault tolerance refers in general to the capability of a certain system to deal with failures, for continuing to operate even if some of the nodes of the component fails. With fail, we mean when, for example, a node crash. In general, a large-scale distributed system has two properties. The safety property, that means nothing bad can happen. So, the violation occurs when we have an execution that leads to a bad state. Or the other one is the liveness property, that stands for the fact that something good eventually happened. In this case, the violation occurs when we enter in a loop in which we can't reach a good state. So, based on these two properties, we have four configurations of our system. Masking, in which the safety and liveness are preserved. Non-masking, where the safety property can be violated. This is not true for the liveness, that is preserved. Fail-safe tolerance means that the safety property now is preserved but liveness not. Graceful degradation, in which the application continues but in a degraded mode. But what are the main fault-tolerant issues? So the main fault is the network fault, since we are in a not-in-shared architecture. And when this fault occurs, a part of the considered network is cut off from the rest. Another kind of failure, if we consider a Byzantine scenario, is the Byzantine failures. That means that the nodes are malicious, and so a system is Byzantine fault tolerant if can also continues to operate even if some nodes doesn't respect protocols or are malicious. There are also other kind of failures like crash failure, transient failures, software failure or temporal failure. The two main processes about fault tolerance are the failure detections, that means ways, method for detect when a failure happens. The most important method is and the most used is a timeout based approach. So after a certain timeout, if a node doesn't respond, we consider these nodes as failed, and we start a procedure for recovery, because the second procedure is the system recovery, so how the system can work again after a failure. For what concerns the timeout, we have to pay attention to the length, to the amount of a certain timeout, because too long timeout means long waiting time and so less availability, while too short timeout means a high risk to declare prematurely dead a node that could suffer only, for example, of a delay. For what concerns system recovery, we have two approaches. The backward recovery, in which we want to move the system back to a previous correct state, or the forward recovery. In the second method, instead of returning the system into a previous state, we want to place the system in a current new state from which it can continue to operate. One of the most important approaches used in fault tolerance and one of the most important algorithms is the Paxos consensus protocol. Paxos is a protocol for solving consensus in a network of possible fallible processor. The main goal is to ensure that a single value among all the values proposed by some processes is chosen at the end of the entire procedure. Okay, we have some agents that are processes, the proposer that want to propose a value, and the acceptors that are agents that following different rules can accept or not some proposal, and at the end the learner that wants to advise all the processes of a chosen value. It's divided in two main phases: the selecting phase, in which the value is selected among the proposal, and the learning phase, in which we inform the processes about this selection value. So for what concerns the fault tolerance provided by Paxos approaches is the fact that for tolerate the failure of a certain number of M servers, the system requires two m+1 servers. Paxos algorithm in practice can be used for electing a leader process when the previous leader fails, for recovery to this fail. We can imagine in fact that a proposer wants to propose a value that is I am the leader, and so when this value is selected means that a certain agent became the new leader. Another algorithm that can be used in a distributed system for providing fault tolerance is the Chord algorithm. The Chord algorithm is basically a lookup protocol that wants to support in an efficient way the location of data inside servers, inside the node, usually in a peer-to-peer architecture, based on the concept of consistent caching. That means we pass to an hash function in input a key, so a value, both for the data and for the nodes. The output of this hash function is a location inside this ring, because the consistent hashing use a space address viewed as a ring space. This method allows to obtain good properties, first of all the scalability and also the efficiency of the algorithm that converge usually to a complexity of log n of the lookup, also when some failures occur, or also when some node leaves or join the ring space. For what concerns fault tolerance, so for increasing robustness against fault, each node maintains a list of a certain number of successors in this ring. We can lead to a wrong lookup only when all the successors in the successor list fail, but this is very less probable that, for example, 10 successors fail at the same time. There are some important differences between these two methods. The first one, for what concerns the approach that they use, so the Paxos use a message passing between the agents for selecting the value, for example in leader election, while the Chord use this consistent hashing method. The architecture that fits very well Paxos is a master-slave architecture, while for Chord algorithm is a peer-to-peer. The complexity of Paxos is capital O of n, while for Chord converge to a logarithmic of n. For what concerns fault tolerance, so in Paxos more than 50% of node can crash and we can tolerate this, while for Chord when 50% of node fails, only 1% of lookups fail, so this is a very good property. Now we dig more in details in some of the most famous and used NoSQL distributed system. The first one that we want to analyze is Neo4j. Neo4j is an open source Java-based scalable graph database management system. Searching in the literature, we have found two methods for fault tolerance and so leader election. The Raft protocol. Raft protocol derives from Paxos, but is simpler than Paxos, and is divided in a leader election phase, so when a leader fails, a new one is elected, and the log replication phase, in which the leader accepts the client request and propagates them to the follower. Another approach that Neo4j can use is the multi-Paxos protocol, a way for executing different instances of basic Paxos, reducing the failure-free message delay and the overhead in the communication. The second NoSQL database system is MongoDB. MongoDB is a general-purpose document-based distributed database. MongoDB also uses a Raft algorithm, but with some important difference. The first difference is that Mongo uses a pull-based approach instead of a push-based approach. This means that the server waits for followers that ask for the changes, for writes operation, for example. Usually is the server that propagates the write request. In Mongo, there is an optimization that modifications are applied directly and after are committed. The user can also select a personalized timeout. We can also assign priorities to the nodes for the election. We don't use in MongoDB snapshots when a new server is added to the system. We add a switching phase by which the leader cannot accept immediately new write requests for not losing data, and the node can have more roles. For example, can be an arbiter or a non-voting member. The last NoSQL system is Cassandra. Cassandra is a column-based distributed database written in Java. Fault tolerance is ensured in Cassandra using some good practices like replication with some replication strategies, the probabilistic quorum system that can allows you to tune the consistency level inside Cassandra, a gossip protocol for sharing information directly between nodes because we are in a peer-to-peer architecture and we don't have a master, and the associated failure detection called fee accrual that can allow you to know if a node is alive or not. So in the end, we can say that fault tolerance is a needed feature in a scale distributed system for dealing with a lot of failures like data loss, neuter fault, leader crash, but also node crash in general. And fault tolerance means also an ensemble of procedures for finding the failures and also for managing these failures necessary for the data survival. Thank you for your attention.